Look up at the night sky. Billions of stars, untold mysteries. For millennia, humans have gazed upwards, wondering about our place in the cosmos. We've built tools, from simple telescopes to grand space observatories, to extend our senses and our understanding. Now we stand at the threshold of a new kind of exploration, not just outwards into space but inwards, into the very nature of intelligence itself. We are crafting something remarkable, something called artificial intelligence, or AI. It is a tool, yes, but one with the potential to reshape our world, to redefine what's possible, much like the discovery of fire, or the invention of the printing press. This journey into AI is one of the grandest adventures humanity has ever embarked upon, a quest to understand and create intelligence. Why should this new frontier, this AI, matter to you, to us, to everyone? Because it's not just science fiction anymore. It's not confined to laboratories or complex equations understood by only a few. AI is quietly, and sometimes not so quietly, becoming part of the fabric of our lives. It's influencing how we communicate, how we learn, how we heal, and even how we dream of the future. Understanding AI is like learning the new language of the cosmos, a language that will help us navigate the challenges and seize the opportunities of this unfolding era. It's about being an informed citizen of an increasingly intelligent world, ready to participate in the conversations that will shape our collective destiny. Imagine a universe of possibilities opening before us. AI promises to help us solve some of the most complex puzzles humanity faces. Think about understanding the intricate dance of our climate, or decoding the secrets hidden within our own DNA to fight disease. These are challenges on a cosmic scale, demanding new ways of thinking and new tools for discovery. AI offers a powerful new lens through which we can examine these problems, processing vast amounts of information far beyond human capacity. It's about augmenting our own intelligence, making us more capable, more insightful. This isn't about machines taking over, it's about humans reaching further, powered by these incredible new creations. The story of AI is a human story. It's a testament to our relentless curiosity, our drive to innovate, and our desire to understand the universe and ourselves. Like pioneers setting foot on new continents, we are exploring the vast landscape of artificial thought. There will be challenges, of course, as with any great endeavor, but the potential rewards, the promise of a future where human ingenuity is amplified by intelligent machines, are simply too profound to ignore. So, let us embark on this exploration together, with open minds and a spirit of discovery, ready to learn about this fascinating field that is already beginning to illuminate our world in breathtaking new ways. So, what exactly is this artificial intelligence we speak of? Think of it simply. AI is the ability of a computer or a robot controlled by a computer to do tasks that are usually done by humans because they require human intelligence and discernment. It's about creating machines that can perceive their environment, reason about it, learn from experiences, and make decisions to achieve specific goals. It's not necessarily about creating a conscious being, like in the movies. More often it's about specialized intelligence, machines that are very good at one particular thing or a set of things. These intelligences are designed by us, for us, to assist and enhance our own capabilities across a vast spectrum of activities. You might be surprised to learn that AI is already woven into the tapestry of your daily life, like an invisible cosmic thread connecting many of your experiences. When you ask your smartphone for the weather, that's AI understanding your voice and fetching the information. When your email program cleverly sorts out spam messages from your important communications, that's AI at work, learning to distinguish the junk from the gems. Even when you're scrolling through your favorite streaming service and it suggests a movie you might love, that's an AI algorithm, analyzing your past choices and the choices of millions of others to make an educated guess about your taste. It's these small, almost unnoticed interactions that show AI's pervasive, helpful presence. Consider the apps on your phone that help you navigate through traffic. They use AI to analyze real-time data from countless vehicles, predict congestion, and suggest the fastest route to your destination. This saves you time, fuel, and frustration. Think about online shopping. AI helps recommend products you might like based on your browsing history and what similar shoppers have purchased. It can also power chatbots that answer your customer service questions instantly, day or night. These are not futuristic dreams, they are practical applications of AI that many of us use every single day, often without a second thought about the complex computations happening behind the scenes, orchestrating these conveniences. Even the photos you take are often enhanced by AI. Your phone's camera might use AI to recognize faces, adjust the focus, and optimize the lighting to give you the best possible shot. Social media platforms use AI to organize your newsfeed, showing you posts it thinks you'll find most interesting, and to identify and filter out inappropriate content. From the music playlists curated just for you, to the fraud detection systems that protect your bank account, AI is working diligently in the background. It's becoming an indispensable assistant, a silent partner, in navigating the complexities of modern existence, making countless small improvements to our efficiency and enjoyment. How does a machine, a collection of circuits and code, actually learn? It sounds like magic, doesn't it? But it's a process, a fascinating journey that mirrors, in some ways, how we humans learn. One of the most important concepts here is called machine learning. Imagine you're teaching a very young child to recognize a cat. You don't just tell them that's a cat once, you show them many different cats. Big cats, small cats, black cats, white cats, fluffy cats, sleek cats. With each example, the child's understanding of catness refines. They start to pick up on common features, the pointy ears, the whiskers, the tail, the way it meows. Machine learning works in a similar spirit, but with data instead of direct experience in the human sense. We feed the AI system vast quantities of information or data. If we want it to recognize cats in pictures, we show it thousands, even millions of pictures, each one labeled cat or not cat. The AI, through complex algorithms, starts to identify patterns in these images, common arrangements of pixels, shapes, and textures that tend to appear when a cat is present. It's not programmed with explicit rules like a cat has 2 pointy ears. Instead, it discovers these rules for itself by sifting through the examples we provide. It's a process of induction, of finding general principles from specific instances. This ability for AI to learn from data rather than being explicitly programmed for every single possibility is what makes it so powerful and versatile. Think about trying to write a traditional computer program to identify spam emails. You could try to list all the words that might appear in spam, but spammers are clever. They change their tactics, their wording. Your list would quickly become outdated. A machine learning system, however, can be continuously fed new examples of spam and legitimate emails. It learns to adapt, to recognize new patterns of spammy language or sender behavior, making it much more effective in the long run. It's this adaptability that truly sets modern AI apart. So, machine learning is like giving the AI a textbook and a lot of homework problems, and it figures out the solutions and the underlying principles on its own. The textbook is the data, and the homework is the task we want it to perform. The more data it processes, the more experience it gains, and typically, the better it becomes at its assigned task. This is why you hear so much about big data in the context of AI. More high-quality data often translates to smarter, more capable AI systems. It's a fundamental shift from telling computers exactly what to do, step by step, to enabling them to learn what to do. Let's delve a little deeper into this fascinating process of machine learning. It's not just one single method, it's a whole field with different approaches, like different ways a student might study for an exam. One common type is called supervised learning. This is very much like our cat example. We provide the AI with labeled data pictures of cats labeled cat, pictures of dogs labeled dog. The AI learns to map the input, the image, to the correct output, the label. It essentially learns by example, with a supervisor guiding it by providing the correct answers during the training phase. This is incredibly useful for tasks like image classification, spam detection, or predicting house prices based on historical sales data. Then there's unsupervised learning. Imagine giving a child a big box of mixed-up Lego bricks of all shapes, sizes, and colors, but without any instructions or pictures of finished models. The child might start sorting them into piles, all the red bricks together, all the square bricks together, and so on. Unsupervised learning algorithms do something similar with data. They are given a data set without any predefined labels, and are tasked with finding hidden patterns or structures on their own. This can be used to discover customer segments in marketing data, to find anomalies that might indicate fraud, or to group similar news articles together. It's about the AI finding inherent order in the chaos of information. Another exciting area is reinforcement learning. Think about how you might train a dog to perform a trick. You give it a command, and if it does the trick correctly, you give it a treat, a reward. If it does something else, it gets no treat or perhaps a gentle correction. Reinforcement learning works on a similar principle of rewards and punishments. The AI agent interacts with an environment, it takes actions, and based on those actions, it receives feedback in the form of rewards or penalties. Its goal is to learn a strategy or policy that maximizes its cumulative reward over time. This is the technique behind AI systems that can play complex games like Go or chess, or control robots in dynamic environments. The beauty of these learning methods is their iterative nature. An AI model is trained, tested, and then often retrained with more data or adjusted algorithms to improve its performance. It's a continuous cycle of learning and refinement, much like how we humans learn a new skill. We practice, we make mistakes, we learn from those mistakes, and we gradually get better. Machine learning allows AI systems to evolve and improve over time, becoming more accurate and more effective as they encounter more data and more experiences. This capacity for self-improvement is a cornerstone of AI's growing power and its potential to tackle increasingly complex challenges across the cosmos of human endeavor. Now, when we talk about some of the most advanced forms of machine learning, you'll often hear the term neural networks, and sometimes deep learning. What are these? Well, scientists and engineers, in their quest to build intelligent machines, often look to the most powerful information processor we know, the human brain. Our brains are made up of billions of tiny cells called neurons, all interconnected in a vast, complex network. These neurons receive signals, process them, and pass signals on to other neurons. It's this intricate web of connections and interactions that gives rise to our thoughts, our memories, our ability to learn. Artificial neural networks are computational systems inspired by the structure and function of these biological neural networks. They aren't actual biological brains, of course. They are made of code and mathematics, running on computers, but they try to mimic the basic idea. An artificial neural network consists of layers of interconnected nodes or neurons. Each connection between neurons has a weight, which determines the strength of the signal passing through it. When the network is fed data, like the pixels of an image, these neurons get activated, they process the information, and they pass it on to neurons in the next layer, and so on, through multiple layers. The deep learning refers to neural networks that have many layers, sometimes dozens or even hundreds. These deep layers allow the network to learn features at different levels of abstraction. For example, if you're training a deep neural network to recognize faces, the first few layers might learn to detect simple things like edges and corners. Middle layers might combine these to recognize more complex features like eyes, noses, or mouths, and the final layers might combine those features to identify a complete face. This hierarchical learning, from simple patterns to complex concepts, is what makes deep neural networks so powerful for tasks like image recognition, natural language understanding, and even generating creative text or art. Training a neural network involves adjusting those weights on the connections between neurons. This is typically done using a process called backpropagation, often with labeled data in supervised learning. The network makes a prediction, for example, this image is a cat. If the prediction is wrong, the error is calculated, and this error information is propagated backward through the network. The weights are then tweaked slightly to reduce the error for that specific example. This process is repeated millions or billions of times with many different examples, until the network becomes very good at making accurate predictions. It's like meticulously tuning a vast cosmic instrument until it plays the perfect melody of intelligence. The universe of AI's applications is vast and expanding, and nowhere is its impact more profound than in the realm of healthcare. Imagine doctors having a super intelligent assistant that can analyze medical images, X-rays, MRIs, kinetic scans, with incredible speed and accuracy, spotting signs of disease like cancer or diabetic retinopathy, sometimes even before a human expert might. AI algorithms trained on millions of medical images are becoming exceptionally good at this kind of pattern recognition. This doesn't replace doctors, but it augments their abilities, helping them to diagnose conditions earlier and more precisely, potentially saving countless lives across our planet. It's like giving them a cosmic magnifying glass for human biology. Furthermore, AI is accelerating the discovery of new medicines and treatments. The process of developing a new drug is incredibly complex, time-consuming, and expensive. AI can sift through massive databases of biological information, chemical compounds, and research papers to identify promising candidates for new drugs, or to repurpose existing drugs for new diseases. It can simulate how different molecules might interact within the human body, speeding up the initial stages of research. This power to analyze and predict at a molecular level is opening new frontiers in personalized medicine, where treatments can be tailored to an individual's unique genetic makeup and lifestyle. a truly revolutionary prospect for human well-being. Beyond the hospital and the lab, consider how AI is reshaping our journeys, the way we move across our world. The development of self-driving cars and autonomous vehicles is a prime example. These vehicles use a sophisticated array of sensors, cameras, LiDAR, radar, to perceive their surroundings, much like our own senses. AI algorithms then process this information in real time to navigate roads, obey traffic laws, identify obstacles, and make driving decisions. The goal is to create transportation systems that are safer, reducing accidents caused by human error, and more efficient, potentially easing traffic congestion and reducing fuel consumption. It's a journey towards a future where our commutes are less stressful, and our roads are more harmonious. AI is also optimizing logistics and supply chains on a global scale. Think about the journey of a product from a factory on one side of the world to your doorstep. AI helps to plan the most efficient shipping routes, manage warehouse inventories, predict demand, and even optimize the final delivery to your home. This intricate dance of goods and services, orchestrated by intelligent algorithms, ensures that resources are used more effectively, waste is minimized, and we get what we need when we need it. From the microscopic analysis of our cells to the macroscopic management of global transport, AI is proving to be an invaluable co-pilot in navigating the complexities of modern life and improving our collective existence. The light of AI is also beginning to shine brightly in our classrooms and learning environments, promising a more personalized and engaging educational journey for every student. Imagine an AI tutor that can adapt to each individual's learning pace and style. If a student is struggling with a particular concept in mathematics or physics, the AI can provide targeted explanations, extra practice problems, and immediate feedback, just like a patient human tutor would. It can identify areas where a student excels and offer more challenging material, ensuring that everyone is learning at the optimal level for them. This isn't about replacing teachers, but about providing them with powerful tools to support every learner in their unique cosmic quest for knowledge. AI can also help create richer and more interactive learning materials. Think of textbooks that come alive with AI-powered simulations, or language learning apps that use AI to assess your pronunciation and engage you in realistic conversations with virtual native speakers. For educators, AI can assist with administrative tasks like grading simple assignments or identifying students who might need extra support, freeing up more of their valuable time to focus on direct interaction, mentorship, and fostering critical thinking skills. The potential for AI to democratize access to high-quality education, regardless of geographic location or socioeconomic background, is truly inspiring, offering a universe of learning opportunities to all. And what about our homes, our personal sanctuaries? AI is making them smarter, more comfortable, and more efficient. Smart home devices powered by AI can learn your routines and preferences. Your thermostat can automatically adjust the temperature to save energy when you're away and ensure your home is cozy when you return. Smart lighting can change its intensity and color based on the time of day or your activity. Voice assistants, those friendly AI companions, can control your lights, play your favorite music, answer your questions, and manage your schedule, all with simple voice commands. It's about creating living spaces that respond intelligently to our needs, enhancing our comfort and convenience. Beyond convenience, AI in the home can also contribute to safety and accessibility. Smart security systems can use AI to distinguish between a pet, a family member, or an intruder, reducing false alarms and providing greater peace of mind. For elderly individuals or those with disabilities, AI-powered devices can provide crucial assistance with daily tasks, monitor well-being, and even alert caregivers in case of an emergency. This application of AI to enhance our daily lives, making our homes more responsive and our routines smoother, demonstrates its capacity to serve humanity in very personal and meaningful ways, bringing a touch of intelligent design to our everyday existence. As we journey further into this new age of artificial intelligence, like explorers charting unknown cosmic territories, it's natural and wise to consider the potential challenges and concerns that accompany such powerful technology. One of the most frequently discussed worries is the impact of AI on jobs. As machines become more capable of performing tasks previously done by humans, from manufacturing and data entry to customer service or analysis, there are legitimate questions about job displacement. Will AI create new jobs to replace the old ones? How do we prepare our workforce for a future where humans and AI collaborate? These are significant societal questions we must navigate thoughtfully. Another major concern revolves around privacy. AI systems, especially those that learn through machine learning, thrive on data. This data often includes personal information, our online behavior, our purchase history, our location, even our biometric data like faces and voices. How is this data being collected, stored, and used? Are there sufficient safeguards to prevent misuse, unauthorized access, or surveillance? As AI becomes more integrated into our lives, ensuring the ethical and secure handling of our personal information is paramount. We must develop robust frameworks and regulations to protect individual privacy in this data-rich, AI-driven world, ensuring our digital footprints don't become cosmic vulnerabilities. Then, there are the ethical dilemmas and the potential for bias in AI systems. If an AI is trained on data that reflects existing societal biases, whether related to race, gender, or other characteristics, the AI can inadvertently learn and perpetuate these biases in its decisions. This could have serious consequences in areas like loan applications, hiring processes, or criminal justice. How do we ensure fairness and equity in AI algorithms? How do we make their decision-making processes transparent and accountable? These are complex questions that require ongoing research, diverse perspectives, and a commitment to building responsible AI. Finally, as AI systems become more autonomous and capable of making decisions with significant consequences, questions arise about control and safety. While the idea of super-intelligent AI surpassing human control is still largely in the realm of science fiction for now, it's important to proactively consider the safety and alignment of increasingly powerful AI. How do we ensure that AI systems operate as intended and align with human values and goals? These are not reasons to halt progress, but rather calls for careful consideration, for robust research into AI safety, and for open global conversations about how we want to shape the future of this transformative technology. It's about navigating the stardust of innovation with wisdom and foresight. So what does the future hold for us in this expanding universe of artificial intelligence? The journey ahead is likely to be a mixture of incredible advancements and thoughtful navigation of challenges. AI is not a destination in itself, but a powerful tool, a new kind of cosmic engine that can propel us towards a future of unprecedented possibilities. It promises to help us tackle grand challenges like climate change, disease, and resource scarcity by providing new insights and solutions. Imagine AI helping to design sustainable cities, optimize global food distribution, or even assist in the exploration of other planets, extending humanity's reach further into the cosmos. The relationship between humans and AI will likely evolve into one of collaboration rather than competition. AI can handle repetitive tasks, analyze vast datasets, and provide instant information, freeing up humans to focus on creativity, critical thinking, emotional intelligence, and complex problem-solving, the very essence of what makes us human. Doctors will work with AI diagnosticians, scientists with AI research assistants, artists with AI creative tools. This synergy, this partnership between human intellect and artificial intelligence, could unlock new levels of productivity, innovation, and discovery, enriching our lives and expanding our understanding of the universe and our place within it. We are on the cusp of augmenting our own abilities in ways previously only dreamed. However, realizing this positive future requires us to be proactive and responsible stewards of this technology. It means investing in education and retraining programs to prepare people for the changing job market. It means developing strong ethical guidelines and regulations to ensure AI is used for good, respecting human rights, privacy, and fairness. It means fostering public understanding and dialogue about AI so that everyone can participate in shaping its development and deployment. The future of AI is not something that just happens to us. It is something we must actively build, with wisdom, with foresight, and with a shared commitment to the betterment of all humankind. Therefore, learning about AI, even at a basic level, is more important than ever. It's about more than just understanding technology. It's about understanding a force that is reshaping our world and our future. It's about being equipped to ask the right questions, to make informed decisions, and to contribute to a future where AI serves humanity's noblest aspirations. The universe of AI is vast and full of wonder. Let us approach it with curiosity, with critical minds, and with hope, ready to harness its power to build a brighter, more intelligent, and more compassionate future for all of us together as we journey among the stars.